Okay, I just told them in section 4.2 we deal with the first and only rule for this section, which is the power rule. There are 4 rules for differentiation or taking the derivative, and the next ones we're going to learn in the coming sections. But 4.2 is just the power rule, that's it. Okay, so when you're finding the derivative of a constant, that's where we're at right now. Derivative of a constant would be just like y equals 7. 7 is a constant number because he doesn't have an x attached to him, right? Constant means no x's, just numbers, right? So think about what y equals 7 looks like. What does that look like if you graph y equals 7?
A line.
A line how?
A line.
What kind of line? A horizontal line at 7, right? 1, 2, 3, 4, 5, 6, 7. Whatever. Horizontal line like this. Okay? Now, if I pick a point on here and try to find a tangent line and find the slope of that line, what's the slope of that line going to be? 0, right? So the slope, or the derivative, is 0. Okay? Same thing here. This is f of x equals 0. So this is a horizontal line at 0. What's his derivative going to be? 0. Okay? S of t equals -3. That's a horizontal line down at -3. What's his slope going to be? 0. Okay? Now, k pi squared. Okay? Let's say our constant is the number 2. So this would be 2 times pi squared. Pi squared would be like 9 point something, whatever. So this number is going to be 18 and maybe some change. I don't know, whatever it is. So that's a horizontal line at 18. All the way up there. What's his slope going to be? 0. So don't let them confuse you with all these symbols in here. As long as all of those are numbers and I don't have any x's attached to him, the derivative is going to be 0 always, right? We did ones before, like before Christmas break, we started doing stuff like find the derivative of this guy, like on the back page. Okay, remember that 5 just drops off, right? When you're taking the derivative of this thing, that 5 just basically goes away because his derivative is 0. Derivative of any constant is always 0. Okay, now this is the power rule. Circle him because this is the like whole big huge thing. Okay, when you're taking the derivative of x to the nth power, the n comes down in front. You subtract 1 from the exponent. Okay, circle it. Do it. Okay, the n comes down in front. Subtract 1 from the exponent. So x to the 3rd power. What does he become? I'm going to go fast. 3x squared. You drop the 3 down in front. Subtract 1 from the exponent. That's his derivative. Done. Okay, now number 2, you're going to have to change him just a little bit before you can take the derivative. So the cubic root of x, we need to write him as an exponent. X to the what power? 1/3. Okay, if you have a square root or a cubic root or something like that, it's a fractional exponent, yeah? Okay, so now the same rule applies. Drop the 1/3 down in front. 1/3 goes down in front. And then when you subtract 1 from 1/3, what is 1/3 minus 1? If you need to find a common denominator, this would be like 1/3 minus 3/3. -2/3. Okay, do you see how that all pans out? Right? Yeah? Okay, now I want that 2/3 to be positive. How do you make it a positive 2/3 power rather than -2/3? Move it to the bottom, okay? So now he's going to look like 1/3x to the positive 2/3 power, okay? And then there's one more thing that we can do. Change it back to like a radical symbol, whatever. What does x to the 2/3 power look like? The other way around. Yeah, it's the cubic root of x squared. This is the derivative of that thing. Okay, that's my final derivative. Does that make sense? I'll give you a second to write that down. Okay, take the derivative and then make the exponent not disgusting. Okay. Okay, number 3 is the same way. I have to change him before I can take the derivative. But I can't take the derivative of stuff that's in the bottom. Move it to the top. So when he comes to the top, he will be what? Yeah, x to the -2. Now, same rules apply as before. Now I just do the same thing. Okay, -2 comes down in front, x to the what? -3. Okay, now fix him again. I don't like that -3. So that becomes -2 over x cubed. Does that make sense? Okay. So, if it's not in like a good format to take the derivative of, switch it. Like any radicals make the turn to exponents. If it's in the bottom, move them to the top. Okay? Good? All right, so I did this example on the board here. Find the slope of the graph of x to the fourth power. Do you guys know what x to the fourth power looks like just by himself?
W.
Kind of. Okay, did I tell you I've been lying to you? Did I tell you I've been lying to you this whole time? Okay, so x to the fourth power, when you have it with other stuff. So I have been lying to you. This is where my calc kids always get pissed at me. X to the fourth power, when he has like other stuff in there, like x to the fourth plus 3x squared plus blah, 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 he looks like a W. Okay? But just x to the fourth power, when it's just x to the fourth power and nothing else, he looks like a parabola, but he's like flatter in the middle. Okay? He kind of looks like a flat tire. So he comes down and he's like a little bit flatter in the middle before he goes back up again. Right? Okay, so that's what just x to the fourth power looks like. Does that make sense? Yeah. Okay. So basically, they're wanting us to find the slope at those points, -1, 0, and 1. Okay. So here is -1 right here. We're trying to find the slope of that thing. 0 is here. I'm trying to find the slope of that thing. 1 is here. I'm trying to find the slope of that thing. Okay, that's what we're trying to do. And you don't have to graph this every time, but just so that you know like what we're trying to find here. Find the slope of the graph. Okay. What are we going to do? Kind of, not yet. Find the derivative first of x to the fourth power. Okay? All right, now I'm going to use this notation because they will use this. If f of x is x to the fourth power, they will call the derivative f prime of x. Okay, so I'll use that notation. So you can see that it just looks like a little apostrophe. Okay, so what will f prime of x be? 4x to the third. Okay, now this will tell me my slope at any point in time along this curve. I just have to plug in what I want, right? So if I plug -1 in, -1 in there, 4 times -1 to the third power. What's my slope going to be there? -4. Okay. If I plug 0 in, the slope is going to be 0. Okay. You could probably take a guess at what plugging 1 in will be. It's going to be the opposite of -1, right? It's going to be +4. Okay. Now let's see if that's consistent with my graph. So here, do you buy that this could possibly be a slope of -4? And this could possibly be a slope of +4. And this is definitely a slope of 0. Does that make sense? I just found 3 derivatives all at one shot by just doing one derivative and plugging it in. That is so much faster than doing like this definition, like the f of x plus change of x, and we'd have to do that 3 times, whatever. Yeah, that's not fun. So, does that make sense, what we're trying to find? Okay, now, find an equation of the tangent line to the graph of x squared when x is -2, okay? Now, here's one step further. Equation of the tangent line, okay? Derivative gives me slope of the tangent line. Okay? So just finding the derivative will give me just the slope of that line, right? Okay, but what does the equation of a line look like? Yeah, so basically they're saying, okay, don't just stop at the m, because that's the slope of the tangent line. Keep going and do y equals mx plus b, right? So we're having to find the rest of it now, right? So what do you want to do first? Find the derivative, okay? So starting with x squared, okay, f prime of x will be 2x, okay? All right, this is the derivative, but we need specifically at the point -2. Plug that in there, okay? So 2 times -2 is -4, okay? So what does that do for me? -4 is your slope. Okay, so -4 goes in for m. All right, so now we are at the point y equals -4x plus b. And I need to find b. And how do you find B?
Plug the point on.
Plug the, yeah, I plug the point in. What is the point? What's that point that I need to plug in for x and y? Okay, -2 is the x, but what is this guy? Okay, they say 4. How did they get 4? You plug it into the original. -2 into the original makes the point -2 comma 4. You see that? -2 squared is 4. Okay, so that's where that 4 comes into play. So not only do you have to plug -2 into the derivative, you sometimes might have to plug it into the original if you're writing the equation. Does that make sense? Now I have my point. So 4 equals, whatever that is, 8 minus 8. Did you get -4? B equals -4. Okay, so the equation of my line is y equals -4x minus 4. Is that right? Okay. So you might have to go just a little step further when you're writing the equation of the total line rather than just finding the slope. Yeah? Makes sense? Okay. All right. Okay, the constant multiple rule. I'll hit on this just a second. For some reason, they thought this needed an extra explanation. So when you're taking the derivative of x to the third power, that's 3x squared, right? But what they're saying is that if you have a number out in front of that x to the third power, like let's say 4x to the third power, what do you do with the 4? You just multiply it by 3, right? So that's what this rule says, that you still do the same procedure, but it becomes 12x squared, right? You just multiply the whole thing by 4. So the fact that it has a number out in front doesn't change what you do. It just means you have to multiply it by that then at the end. Yeah? Okay. All right. Number 1. So this is kind of like in a table format here, right? Okay. Rewrite, differentiate, simplify. So this is where you actually find the derivative. The rewrite to start with means that if it's not in a nice form to take the derivative, make it in a nice form. Like 2 over x. Can you take the derivative right now? No, not yet. What do you have to do? Yeah, what? Yeah, move the x to the top. He goes to the top, and he becomes 2x to the -1. So I have rewritten him, and I'll call him y. Y equals 2x to the -1. Okay? Then I'm going to take the derivative. I'm going to differentiate. So when I'm taking the derivative, I can still call him y, but he needs to now be y prime. Okay? Just like we used f prime. Now that means that's the notation that we use after we take the derivative. Okay? Y prime. What would that make? -2x to the -2, okay? And then there's a simplify column because they don't like that -2 exponent. So y prime will be something. I don't know. -2 over x squared. So this is my final answer. Yeah? Okay, okay, yeah, number 2. I'll do it in a different color. We might skip some of these, but not number 2. Okay, number 2. 1 over 2, that's really disgusting. Okay, so what are you going to do first? Change the thing, the cubic root of x squared. What is that as like an exponent? 2/3. Okay, so this is 1 over 2 x to the 2/3 power. Yeah, like that? 1 over 2x to the 2/3. Okay, now I'm still not happy with that. I still want to rewrite him. Okay, bring him to the top. Okay, and when I bring him to the top, I'm actually going to detach him away from the 1/2. Can I do that? Like 1/2, and then this is x to the -2/3. That would be like the same thing as x to the -2/3 over 2, right? This is the same thing as this. So I'm going to detach him from the number out in front, right? Okay. Now he's ready to find the derivative. Okay, this is where it gets sticky. Make sure you're writing this down. Okay, all your steps are going to be really important, and your handwriting can't suck. One table in particular. Yes. Your handwriting cannot suck at this point. Okay? All right, so move the exponent down in front. One half is already down in front. Move the exponent down in front. I have to multiply by 1/2. Okay, so what is 1/2 times negative 2/3? Negative 2/6, or the 2's can cancel out, right? How about negative 1/3 x? What? What? Did I lose you? 1/2 times 2/3, the 2's can cancel out, so negative 1/3. Does that make sense? Yeah? Crazy. Okay, exponent. What's the exponent going to be? Negative 2/3. And if you subtract 1 from that, this would be like subtracting 3/3 from already a negative 2/3. So, yeah, I think Jazz said it maybe. 5/3, negative 5/3. Okay, I'm trying to write as best I can. Okay. All right, now let's fix him. Let's simplify him. Let's move him back down. Okay, so if we move him back down, negative 1, 3x to the 5/3. What? Okay, last one, y prime, finally, is something. Yuck. Negative 1 over what? 3. The 3rd root of x to the 5th power. There he is. Good, good? Did I lose anybody?
Disgusting.
Disgusting. But you found the good. There you go. I didn't promise to give you next. There you go. Okay. Number 3 is very similar to number 1, except I'm gonna get you started on it, and then we might skip it. Okay. So number 3, let's get rid of the parentheses first. 8x to the 3rd power, right? You've got to do the 2 also, right? The cube of 2. So this guy, if we rewrite him, I'll do a different color. Okay, if I rewrite him, this is 5 on the top. 2 to the 3rd power is 8, and x to the 3rd power is like that. Okay, now he's very similar looking to what number 1 was. Okay, how are you going to rewrite him? 5/8 x to the negative, yeah. And when you bump him to the top, I shove him off the side. Does that make sense? I don't leave him up there with the 5. I put him off to the side. Right? Okay, just like that. You want to keep going? You want to try it? You want to finish? I'll give you 30 seconds. Can you finish it? Or maybe a minute. Okay. You keep going. Take negative 3, multiply it down in front. Just leave it as an improper fraction. See if you got the same as me. I might have done that wrong. I'm a little rusty. When you multiply the negative 3 in front, like treat it like it's negative 3 over 1. Right? When you multiply him down in front, it's like negative 3 over 1 times 5 over 8. So 15 over 8. Right? Did you guys get that? Are we good to go? Do you understand what's going on? Yes, yes? We're good? Okay, last one. Okay. Okay. Number 4 is actually easier than you think. What are you going to do first? What are you going to do on number 4? That's what I would do. So a lot of people are tempted to distribute the negative 2 through. I would move it to the top before you square it because we want it to be positive. So that 7's just going to chill out, okay? And then when we move him to the top, He's just going to be 3x to the positive 2 power. All over, basically 1 is on the bottom now, which we really don't need. But if it helps you to put it there, that's fine. Okay. Now, 3x squared will become 9x squared. I'll rewrite that here. 9x squared. Okay. But that is just what? Because the 3 is also squared. Because the 3 is inside of the parentheses, you have to square the 3 also. Okay. So 7 and 9x squared on the top. We're going to multiply those. What? I don't know. I don't know, babe. What is 7 times 3? Or 7 times 9? 7 times 9. Do you guys know the rule of 9s? Have they showed you how to do that?
660. What's 56? 8 times.
Oh my goodness. Oh my goodness. Okay. Don't write. Just wait. Just wait. You're going to get an education here. This is something you should have learned in like 5th grade, but this is like a trick, right? Okay. So, 9 times 0 is just 0, right? Okay. 9 times 1 is just 9, and I'm going to put a 0 in front of the 9 because I'll show you why here in a second. 9 times 2, 9 times, you don't have to write this down. 9 times 4,
18.
You're just going to get an education here. 9 times 5, 9 times 6, etc. Blah, 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 blah. Okay. Okay, here's the trick, right? What's the number less than 2? Which one is less than 2? The number 1. Okay, what do you have to add to 1 to get 9?
8.
8. Okay, what number is less than 3?
2.
2. What do you have to add to 2 to get 9?
7.
7. What number is less than 4?
3.
3. What do you have to add to 3 to get 9?
6.
What's less than 5? 4. What do you have to add to 4 to get 9? 5. What's less than 6?
5.
5. What do you have to add to 9 to get 5?
Oh no!
Does that make sense? Like
You're
it's
missing
1
the
less
next
and then
one.
add to get 9? Yes?
Or you just add 9
So-
to each problem.
Cade.
Exactly.
Yeah, just add 9 to each problem, and you'll
Yeah.
find it.
Whatever. I guess whatever.
Maybe we should learn how to do that instead of flashcards that
I
I
don't
didn't
know.
do.
Or do you guys know this? Okay,
That's 10.
this is 10, right? Okay, so here's the hand trick. If you want to do the hand trick, okay, I'll go this way. Okay, look at my hand. If I'm wanting to multiply by 3, this way. If I'm wanting to multiply by 3, are you ready? Are you doing the same thing back here? You're teaching her. Okay, so this, if I wanted to multiply, let's say I'm wanting to multiply by 4. I put my 4th finger down. 3, 6. I wanted to multiply by 7. Putting my 7th finger down. 63. You see that?
I didn't get it.
Okay. All right, what do you want to multiply by?
Just do 2 times 2.
7.
9 times 7. Okay, I'm going to put my 7th finger down. Left to right, this is my 7th finger. You see that? I'm putting my 7th finger down. Sticking up, there are 6 fingers, and then 3 after the break. 63. You see that? Okay. All right, I'm going to multiply by 5. So I'm going to put my 5th finger down.
That's
Wow.
45. What do they teach you?
Nothing,
In, like junior high and elementary or whatever.
What about
Nothing.
5 times 5?
Listen.
This is for 9s, Kate.
Exactly.
Yeah.
I'm working all my
Yeah,
problems.
5 times 5.
Whatever. So, Cade, are you ready for this?
No.
What is 7 times 9? 1 less than 7 is 6.
63.
63. Woo, man. I am so glad. So glad. I really should have been like a junior high teacher. So I could teach them all. Like, do you guys know same sign sum, different sign, different one? Ah! This is why people
same
suck
sign
at adding
sum.
negative numbers.
Same sign, sum, what's the
So
solution?
sorry if you're watching this video. I'm using an opportunity to teach them something they should have learned in like 3rd grade. Okay, this is why my Algebra 2 kids suck at adding negative numbers. Okay,
Why don't
so
you teach them?
I do teach them this. Now I do because I realize that they don't know how to do this. Okay, so the rule is same sign, sum, different sign, difference. Okay, difference means subtract, right? So sum means add. Okay. All right. So it's easy for kids to see that like 9 minus 2 is 7, right? okay? Because this is a positive 9 and a negative 2, so you take the difference of them because they are a different sign, okay? But if I would say 2 minus 9, they're like, how do I do that? 2 minus 9, because 2 is, like, 9 is bigger than 2. Like, how does that work? It's a positive 2 and a negative 9, right? They're a different sign. You're still going to take the difference. What's the difference of 2 and 9?
If people don't
7,
understand this, they need
okay?
to go back to their
So you're still doing the difference. Different sign, difference. They have a different sign. One's positive, one's negative. You're taking the difference. 9 minus 2 is 7, but which one's bigger? The 9. So you put a negative in front of it, okay? Now, if they have the same sign, like 2 plus 7, that's a positive 2 and a positive 7, so I'm adding them together, and it is 9. Positive, okay? Also, negative 2 and negative 7 have the same sign. Same sign, you still add those. Even though you're technically subtracting, you still add them together. 2 and 7 make 9, but since both of them are negative, you make it negative. Same sign sum, different sign difference.
Okay, now they're back.
Okay, all right.
Right.
Whatever. Whatever. That confuses you? Well, since you know what it is now, but like the kids that like I have that are like, I don't know how to add. Or I'll say like, what's negative 3 minus 2? You're at negative 3. Subtract 2 more. Like if you're 3 below 0 on a temperature, and you subtract 2 from that, you're 5 below 0. It just baffles me. I have juniors that can't do that.
I know how to do it.
Okay, all right, so Cade has figured out that it is 63x squared. All right, great, we're at this point. Have we taken the derivative yet? No, we haven't taken the derivative yet, so we gotta do that now.
I won.
You won. What'd you get? Okay. She's like, I don't know if my math is right. 2 times 63.
63, 120 plus 126, so.
That's it, right?
Yep. I'm just gonna put y prime in the front so that I make myself happy. And I don't have to rewrite it. So that one was like the easiest one of all, but it looked the most disgusting to start with, probably. Right?
Yeah, okay.
Yay!
Oh my God, there's a
Yay! And there's the backside. Oh my goodness sakes. Okay.
Tomorrow?
All right. We'll do 1 and 2 together, real quick, and then we'll stop. Then we'll do rates of change together. Okay. So this rule up here, the sum and difference rule, says this is what it says. If you have a string of these together, you just take the derivative individually. So like this one has 3 pieces. I'm just going to do x to the 3rd power, the derivative. Then I put the derivative of negative 4x. Then I put the derivative of 5. Like it doesn't confuse you when they're all in a string together. You're just taking 3 derivatives and writing it as a string. It changes nothing when you're adding, subtracting, okay? So f prime of x is what we'll call him, okay? Derivative of x to the 3rd power. 3x squared. What's the derivative of negative 4x? Just negative 4, right? The 1 comes down in front. It's x to the 0 power. You will find that will happen every time you have just a number times x. The x will basically drop off and the number is just left there. And what happens to the 5? It goes to 0, so you could put plus 0 on the end of this if you wanted to. But this is it. This is your derivative. Okay? Crazy. Number 2.
Ooh.
Oh, man. I do not like the way that first term is written. Yes. So let's switch him. Let's make him negative 1/2 x to the 4th power instead. Because I'm going to shove that x to the 4th power off to the side. Okay, now we can just take the derivative like normal. What's the derivative of negative 1/2 x to the 4th power? Negative 2, because 4 times 1/2 is 2. X to the 3rd. You got it. Okay. 3x cubed. What's that? 9x squared. Okay. And minus 2x becomes minus 2. And what do you want to call it? G prime of x, because it was named g of x to start with. There we go. Beautiful. Beautiful. Good, good? Yes?
No.
All right, we'll stop. We'll stop. Okay? You can probably start on the homework. There is, like, basically all of it you can do. But we'll take it easy.